Hi, I'm Naman Sheth, and my deep mentors are Chris Shanks and Carlos Rodriguez. And this is the analog seismograph. So to give a little bit of introduction to why we're trying to do analog seismograph. So it's supposed to be like a complement to the digital seismograph that we have downstairs already in the deep lab. So the idea is to give some sort of visual intuition to people who are using the demo uh, for as to how we are able to leverage harmonic oscillation to uh, convert into like pen and paper vibrations that we can actually see, and then possibly even go as far as explaining how we can decompose that signal into uh, constituent frequencies so we can see um, what event actually triggered the seismograph to oscillate. And based on like signature frequencies of different events and event types. So yeah, the idea is to just demonstrate like real world use cases for seismographs, and then in the long term, uh we want to be able to use we want to be able to like actually build a shock transmission mechanism that we can connect to the seismograph uh in order to have someone be able to stomp on the plate of it and maybe even pair it up with the digital seismograph so they can see in parallel uh both acting at the same time so that they can have like a solid sense of what's happening. So in the future, we want to stabilize the actual weighted mass that is held on the spring so that it can oscillate on a paper surface and write out its waveform of whatever vibration was imparted into it by like the shock transmission mechanism. And we need to do a little bit of tuning on the springs so that we can make sure that are damped and oscillate so that um, major seismic events stand out, and more background noise is tuned out so that any major events can be more pronounced so we can more aptly interpret them. So if you see on the left, it's not much, but we have like a demo of the initial, uh, at least spring mechanism. We wanted to demonstrate harmonic oscillation. We don't have an effective shock transmission mechanism yet, but the idea is to have something that can take just vibrations from the ground, like for example, a stomp, and impart that into the spring so that it oscillates vertically and stably so that it doesn't have any other directional motion, just purely in the Y component, or and maybe in the future we'll adjust it so that it's only X component, as illustrations on the side right here. And that would be a nice sort of addition to this demo. And in the future, um, we might even it might be possible to even eliminate uh the springs and have some sort of um oscillation from just like a wire or stiff string that can um freely allow like some sort of pen to draw a waveform onto a paper surface as it rolls along. But yeah, I think that is all for my deep demo this semester. Thank you for watching.